Have you ever just stopped and really looked at the world inside your screen? I mean, it's this whole universe, right? Full of vibrant photos, crystal clear music, endless conversations. But underneath all of that amazing richness, there's a secret, a surprisingly simple one. So let's pull back the curtain and find out what language your computer is really speaking.
While we see this incredibly complex and colorful world on our desktops and phones, our computers, they see something totally different. I mean, way, way simpler. It's a world that's been stripped down to its absolute most basic elements. So, what is that fundamental reality?
Well, this is it. This is the big secret. Everything, your emails, your favorite song, that cat video you just watched, it all boils down to a massive, intricate sequence of just two numbers, 1 and 0. It's a system called binary, and it is the bedrock of everything that happens in the digital world.
Okay, so to really understand this language, we have to start small, like ridiculously small. We're going right down to its most basic letter, the absolute smallest piece possible. And that smallest piece is called a bit. Seriously, think of it as a single atom of information. All it can be is one of two things, either a 1 or a 0. That is it. Every single piece of data in our digital lives is built up from these tiny little things.
It seems kind of limited, doesn't it? Why just two choices? I mean, we humans use 10 digits in our everyday lives, so why would computers hamstring themselves with only 1 and 0? Well, the answer isn't some complex mathematical reason. It's actually about physics.
See, deep inside your computer's brain, there are literally billions of microscopic switches called transistors. And a switch, well, it can only be in one of two states, right? It's either on, which we represent with a 1, or it's off, which we represent with a 0. That simple physical reality is why binary is the native tongue of every single computer.
All right, so we've got billions of on and off switches. Cool. But the next massive question is, how in the world do we get from a simple switch to representing the incredible complexity of our entire world?
Yeah, think about it. How do you write a novel or send a text message with that perfect emoji using only 1s and 0s? Well, you need a translation guide, right? Some kind of dictionary that connects the computer's super simple language to our rich, complex one.
And that digital dictionary is called a character set. It's basically a big rulebook that assigns a unique binary code to every letter, number, and symbol. An early standard, ASCII, was a huge step forward, but its main weakness was that it was pretty limited. It could only handle about 256 characters, mostly for English. The modern strength, though, comes from something called Unicode. It's so comprehensive it can represent millions of characters, covering just about every language on Earth. Plus, you guessed it, all those emojis we can't live with.
Now, this is where it gets really interesting when we talk about things that aren't text. For pictures, we basically create a giant grid of tiny dots, or pixels, and we assign a binary code for the color of each and every one. The more bits we use for each pixel, the more colors we can display. Simple enough. But for sound, it's a totally different game. We actually take a rapid-fire snapshot or a sample of the sound wave thousands of times every second, and we record each measurement as a binary number. The more bits you use per sample, the more accurate and higher quality the recording sounds.
And these formulas show you exactly how that works. For an image, you just multiply its dimensions, the number of pixels, by the color depth, which is just how many bits are used for each pixel's color. For sound, you multiply the sample rate by the duration and the bit depth. It's all just multiplication, turning the physical world into a total number of bits. And this is the exact math that determines if a photo is too big for an email, or how many songs you can cram onto your phone.
So this leads to a really crucial point. It creates this constant trade-off. A super high-resolution photo looks incredible. That's its strengths, obviously. But the weakness is that every single extra pixel and every additional color demands more and more bits. Just to give you an idea, one uncompressed frame of a 4K movie can be over 24 megabytes. It's why file sizes get so huge so fast and why there's always a balance between quality and size.
And that brings us to our next big challenge. We figured out how to create all this data, but now we're basically drowning in it. We need some systems to actually manage and make sense of it all.
I mean, a single photo can be millions of bits. A movie can be billions. Can you imagine trying to tell someone a file is 32,768,000,000 bits long? It's just not practical. We need bigger units, bigger words.
And the solution is actually pretty straightforward. We just group them into a clear hierarchy. Just like we group grams into kilograms, we group bits into bytes, kilobytes, megabytes, and on and on. This gives all of us a simple, common language to talk about storage space and file sizes. And here's how that ladder builds. We start with that single bit. Then you group 8 of them together and you get 1 byte. Now from there, things get a little weird. We scale up in multiples of 1024, not a nice round 1000. That's just because computers think in powers of 2. So 1024 bytes make a kilobyte, 1024 kilobytes make a megabyte, and so on up the chain. This is the system that lets us make sense of the absolutely massive scale of our digital world.
But there's another problem. Even if we can measure the size of a file, actually trying to read a long string of raw binary code is a total nightmare for a person. It's just a sea of ones and zeros. It's super easy to make a mistake and incredibly confusing to look at.
The solution for this is actually really elegant. It's a system called hexadecimal. Instead of just 2 symbols, it uses 16, the numbers 0 through 9, plus the letters A through F. And here's the magic. Each one of those hexadecimal symbols perfectly represents a unique group of exactly 4 bits. This creates this beautifully tidy shorthand, letting us condense those long, scary binary strings into something much, much easier for people to read and work with.
So let's bring this all together. We've gone on quite a journey, right? From a single physical switch all the way to a system that can represent pretty much anything.
So let's recap this whole journey of data. It all kicks off with that humble little bit, that simple on-off switch. Then we group those bits into bytes to start forming a universal language. We use those clever mapping systems like Unicode to translate that language into text, images, sound, everything. We have to invent larger units, kilobytes, megabytes, gigabytes, just so we can talk about how much data we're creating. And finally, we come up with shorthands like hexadecimal just to make it all readable for us humans.
When you really step back and think about it, what this all means is something pretty profound. The entire digital world, with all of its richness and complexity, is really just an elaborate illusion. And it's built entirely from the 2 simplest symbols you can possibly imagine, a 1 and a 0, an on and an off.
So, here's a final thought to leave you with. The next time you see a file size listed in megabytes, or you're watching a high-definition video, you know what's really going on under the hood. You understand the computer's secret language now. So my question is, what will you see differently in the technology that's all around you?